to go. Yeah. Okay. Welcome. Welcome to my first live stream of my lsm-tree based key value store that I'm writing in C. So I've worked on this project for a while now, very slowly. So I started like a year ago. Yeah, and now I'm still not done. And now I'm gonna work on merging the mem tables and the SS tables and all that, because that's functionality that's missing. But for now, things kind of work. I've changed a lot, so I haven't been able to... What is this? Okay. Yeah. LZ4 not found. What? I thought I fixed this yesterday, but somehow the changes didn't get saved. Okay. That should do it. Yeah. So yeah, just to test this out. This is kind of, it has its own binary protocol. So I wrote the server code myself. And yeah, it has its own binary protocol with length prefix strings. And it works. I think not completely. I don't know if this works. It does. Yeah. And it writes to disk. So if you look at this line of code, for example, I don't know if that gets updated. Yeah, see, there are some errors. Yeah, but the idea is that once this limit is reached, these are dumped to disk. So obviously, okay, we're gonna debug this now. Let's go with. Let's start with this. So I'm gonna set something. Oh well, it's not there yet. Run. It's not making with debug symbols. Oh no, it is. Okay, let's try again. GDB code signed. Bull. I hate this. Okay, I have to fix this code signing issue. I've been coding this in my work laptop because I have my setup there, so there's a lot of stuff I have to fix. So a second. No, let me do it off screen. Access. Okay, my certificates. Okay. I already have one. Okay. not expired. Okay, well, I think I can try this. Expand trust. Trust when using the certificate, code signing, always trust. Okay. Okay. Oh. Let's try signing. Okay, I think it should work now. It is signed. Oh, this failed. Did it fail? No, it didn't fail. Okay. Uh, do I have to restart? Okay. Is LDB there? Well, we'll use that. It's probably the same thing. Yeah, okay. Fair enough. Yeah, great. What are you talking about? What? Okay. And then I'm gonna delete and I'm gonna try to set again. That's what's caused the issue. Yep. It has the backtrace. Okay. Oh, I think I know what's up. The server key is not deleting. Delete. I don't know if that's the. Yeah, insert internal. So I'm removing. Ah, okay. The problem is that when I'm adding a tombstone. But wait, is this even necessary? I used to not have this. Like, for the actual skip list, do I even need this? Yeah, I do, because if a value, like, I'm not able to serialize otherwise, right? Because if a value got deleted, and then I dump the next mem table, I actually don't know that. It's just missing from the list. So if it's missing from the list, that's not a way to tell. Right. Think about it like this. Let me show you. So, right, so I have some so-called mem tables. Let me disable my this. Yeah. Okay, so I've got mem table. Maybe I'll just copy this. Yeah. So old, new, or let's say, and let's say key is here, but it's not here. So the thing is, if you just search in this mem table and the key's not there, you can't say it's deleted because it might be in an older table. And the issue is that when you search in, like, basically you can't differentiate between two cases. When you have a key that's in an older mem table because it was added earlier, and when you have a key that was deleted. Because think about old non-deleted. I think I need to scale this way off. So if I have if I have this key, this is a completely valid key. Like this, and this is deleted key. So if I don't have any tombstones, there's no way to distinguish between these two cases, which is an old key that hasn't been deleted because, you know, it's just added earlier and then it hasn't been touched at all at the newer mem table, but the other one, this one was deleted in the newer mem table. So I have to store tombstones. And I have a bug in my tombstone logic because when I get to this point, when I see that it's been deleted, I think at that point I have 3 entries. So I have basically, let's say, key. I'll actually use a specific example. So if you look here, the key is A. So at first I have A and U. No, let's just go back to this. So, I have the pair AU, and then I have with tombstone on 0, by the way. So this is the tombstone. Then I have A1, I think just empty, because that's what I do in the case of deletion, if I'm not mistaken, right? When I delete, I just, when I delete, I actually free up this value completely. So it's like having an old, well, no, I have a pointer to a value, but that's like gibberish. Okay, anyway, and then I call get. So the first, do I have a laser somewhere? Yeah. So the first request, it sees this. It sees this. And then it sees this, I guess, because the deletion comes after. Actually, it's worse. No, okay, so during deletion, what I do is I just changed, no. See, I misunderstood my own code. So at first I have this, and then, actually more specifically, I will say you pointer, and this thing is pointing to my string, right? Like it's a u struct, or well, l string u. And in the second call, what I do is I have like gibberish here because it's freed. So, and I set this to 1. And the get tries to access this because the get logic is not aware of it is aware of tombstones, so that's surprising. And it's being called at 160. That works fine. It's on the second when I try to rewrite it. That's the problem because I've already set it to 1. So So I'm trying to write it. And by the way, this is a tombstone. This is basically, should I delete or not? It's a flag, so kind of like, what do I do with that value? And I see in this case either it's 0 and it tries to free it again for the same key, so you get a double free. That's why what I should do here, I got it. So I should set this to null. And here I just go if current value, free it, otherwise well, yeah, exactly. If it's there, then you free it. Oops. Okay, that's the fix. So let's quit, make, restart. Okay, so now I'm gonna set it to something. I'm gonna delete it. I'm gonna set it to something else. And if I get it, aha. So it doesn't see it. That's because I didn't change the tombstone. Right. So this is also wrong. I also have to set this to 0. Yep. Okay. So we got make. Let's start. So set, delete, reset, and then we just get it. Yeah. So that works fine. I also wonder, do I actually update my bytes used based on this? Because if I delete active memtable, go to the delete, do I actually change the value for my, now this is my set. Or do I change the value actually? Does this have a, does my skip list have a size? It does. Size in bytes. So size in bytes. Right, it's only increased. And when it's deleted, it's not decreased. So I will go with minus equal to the length of the value. When I delete it, yeah. So that's some accounting I didn't do. So interesting here, it still says 2. Always at 2. I wonder why. Size in bytes. Because I'm not in. This is kind of a problem when I'm not inserting anything new. Because this only happens when I insert something new. When I'm not inserting anything new, I don't get any updates, which is a bad thing again. Because now I have to go is equal to the what I'm adding, so value length minus that. And this is kind of one of the bad parts when you have U16s, because I need to go like this. I need to go here, and I think this will work, because it's probably a pitfall here if I do this, because if this value is negative, I don't know how this gets computed, but yeah, if this gets, basically, if this expands to something like, so plus this is bad, because if it shortens, it's gonna, and we can test this. So I'm gonna test this logic. So I'm gonna quit here. I'm gonna remake, build, run. Okay. So if you look at this, so I'm gonna go from a longer string to a shorter string. So longer, right? And if I go short, look at this. Yeah, that's horrible. In fact, did this write something? Yeah, so bad. So pitfalls, okay? You have to make sure. What the hell? I just undid one thing and it, what? Yeah, okay, whatever. Ah, my autosave isn't working. I think this is why this stuff's happening. Look, if I just go ABC and then yeah, I don't know. I feel like my autosave is not working. So if I refresh, wait, look, I'm gonna save at this point. I'm gonna add a few lines and I'm gonna go, okay, this doesn't let me, but I was hoping it would autosave anyway. Okay, but yeah, this logic is, you have to be careful. So you have to first, so you have to assume that this is always like larger than whatever you're minusing. I mean, it can never go negative logically. Okay, so you do this first. Size in bytes minus equal to this. Okay. Cool. So yeah, see, this is, you always have to do accounting. Anyway, little bugs, and when you don't have tests, like it's the case here, you kind of miss out on that. But anyway, no ln run, and now we can longer. Oh, it failed again. What? Oh, of course, again we have an issue. Wait. We went from short to long, so if the previous value was 3, then you add 10 and you remove 7. Well, that should work. Did I not I thought I recompiled. No. Really bad, what's happening? So size is at first 3, and then longer has size 7. So size is 3, and then next call we have value len, which is what is added, which is 7, and current value len, which is 3, right? So 3 plus 7 minus 3 should be 7. Okay, let me print value len. Right, so value len, current value len, and probably size in bytes. Okay, so let's remake. Oh, current value is 32960. What? But that can't be. Okay, I just destroyed my terminal. Okay, let's go to skip list again. How can that be? So let me just print current. We have to go with current value and current value, data current value. What's wrong with the scrolling? Is it a matter of printing? They're all U16s, maybe? Oh, sorry. Well, I can, okay, I'll fix this. Whatever, I don't think that matters, but here it might. Oops. Anyway, this is weird. Does this even compile? Bad access. What? Oh, yeah, of course. Access after free. I'm freeing the value. I have to do this math before, and only at the last moment does it make sense to free. Yeah. Okay. It's gonna work now. I wonder why it's off by 1 for some reason. Oh, well, it includes the key. So if I've got this, it should be 9. Oh, okay, interesting. Thought it was gonna be 9. That's interesting. Thought I had. Oh no, but I have the previous. Look, I have to delete the old key. So now I have 4, and now I would have hopefully only 9, but I have 10. I guess during deletion, I don't. This is a problem. When I delete a key, I don't. When I delete a key, I don't delete the key. I only delete the value. Yeah, I only delete the value. So the key is still in memory, otherwise I would lose the ability to, like I would lose the whole record, so I have to keep the key. So that's why that's there. Yeah. Okay, well that has interesting mechanics, but cool. This is fine now, so okay, so to make this logic uniform, I will say this. I'm not validating for 1 or 0 tombstone here, which is maybe a bad idea, but it doesn't matter. Okay, so let's just check the logic. Length update, I'm deleting the value, therefore I have to update this. And there's another bug. If I try to delete something that's already deleted, I'm gonna have a bug here. Check this out. So I'm gonna delete A. I knew it. So if I try to delete something that's already deleted, so I always, bro, I'm just going one line up. What is going on? I literally just pressed K. Yeah, I have to do this. And that could have been null, so I have to watch out. No, so I'll do this. Yeah. And there's probably things I can do to get the null path like out of the way, because it's shared in both. Yeah, there's another problem here, which is if it's been deleted, well, no, if it's been deleted, that's going to be 1, but I think I would say that this is probably shared logic. So yeah. So this is dangerous. So therefore, look, I'm gonna be adding the size anyway. Yep. So I'm gonna be adding the size anyway, and in one particular case, I'm going to be removing it. Look, here's the idea. Regardless of whether I update or delete, I have to remove the size in bytes, and regardless of whether I update or delete, I have to add the new value size. And the only difference, the only difference is, what do I do in this case? Because this is shared. Like, if it's a delete is just a special case where then you set the value to null. You can even leave it as it is and ignore it, but we set it to null for like safety. I mean, safety again. Yeah, well, whatever. Just for correctness sake, let's say, even though that can still cause issue later, so it's not safe. Otherwise, you set it to the value. because yeah, in the case of quite literally, if you look at the internal, it's this. So, I mean, technically, it's this. No, in case of yep. So this is kind of like shared logic, but then it means that yes, then it means you have to then it means this fails. So I have to go if value. So I don't know what's like more efficient code. I have to do 2 checks here, 1 and 2, versus previously. So let me just copy this somewhere. And previously what I had was, if I just go back, all the way back. I think this is the final correct code. I think I have more paths here. I have one, like, I have the path that this is taken and this is taken. So that's one path. This isn't 2 paths, 3 paths. Versus, I have 4 paths technically, but I have 2 checks. Well, there I have 2 checks too, so I have no idea, like, maybe I'm like this. What is the better state management? Intuitively, it's like, is it a delete or is it not a delete? And here I'm kind of like implicitly handling, like, because what's the delete case? The delete case is this is null. No, well, there are 4 cases. If you think about it, there are 4 cases. Delete a deleted, delete an existing, update, insert, deleted, upsert deleted, upsert an existing. So this is value. So this is the table. Let's just go. Here you have current value, tombstone. So this, that's easy. So that's null, and of course 1. Then you have a pointer, non-null, like, and then you have null and 1, and here you have a null. It's just the combo of these two basically. 0. Kind of the last column is a pointer 0. So these are the cases that you have. And really, if you kind of think about it, you always have 2 checks. So it all depends on this or this. But you have different behavior, because if you look at the size and byte is kind of consistent. Well, here it moves by delta. I have to look at the delta. Oh, it's 0. Nothing changes. Minus current value length. If you upsert a deleted, it's plus curve value len, yeah, and here it's plus curve value len minus value len, yeah. Yeah, and so, I mean, I would like to look at Compiler Explorer here, honestly. Like, I don't know how to, let's look at Compiler Explorer. So I'm gonna create like a function. Okay, so I'm gonna look at this function. I'm gonna have a void foo, which is going to have a no, okay, no, I'm gonna have a which is going to be a data and int length. Okay, I'm gonna create this. I don't care. So I'm going to have a current value. I'm gonna have a value. Oh, I forgot. I'm just gonna name this foo. Yeah, just foo current value, and I'm going to have a int size. It's going to get updated. So the idea is I'm going to write the first code. So I'm going to write if value size value length. Oops, sorry. And then I'm going to write if current value, then size current value length. At the end, I'm going to have current value is equal to value. And here I'm going to have let's just say I have a free function which takes a pointer, yeah, whatever. This exists, so I'm going to call free, although I don't know if that makes a difference, but let's see. Okay, so that's code number 1. And I have, oops, no, I don't want that. I'm gonna write bar here, which is the same signature. Let's just copy paste bar. And it's gonna look different. It's gonna look like this. So it's gonna look like that uses a tombstone, and the tombstone was synonymous with value. So I'm gonna, okay, so this code can actually be simplified by checking on value instead of true. Well, no, that doesn't help. So I'm gonna go if value, if curve value, then you go size minus interval curve value length, and then ls free curve value. Yeah, I'm gonna extract that, so I'm gonna do curve value anyway. Yeah, and the return doesn't matter because, again, it's second if else, okay? Otherwise, I'm going to go with size value length size. Actually, I'm going to go unsigned because that's important for why I'm doing that, so it doesn't get optimized. And then I'm checking lstring free. Oh no, sorry, ls free. Curval. Yeah. Oh, and technically, no, I need to. Obviously, that's incorrect. Yeah, but this code is incorrect. Like, how is it? Oh, sorry, no. If not value. Or if value is null. Yeah, whatever, 0. It's null. And if I just optimize it, which one's simple? I think this is simpler than this. This has way more stuff going on. On pure instruction count. I mean, it's also because, by the way, this order is wrong. It's because I have some duplication. It's because this logic is shared. Because, I mean, the moment you look at this, your temptation is to yeah. Obviously, this is less efficient if I actually, I mean, is it actually smart to add O2 if it can't do it with O2, it's not good. No, just use C11. Okay, C. Well, it's not, just don't consider this a C++ source. Can I just change this C source? Like, yeah, just use a C. Oh no! Don't do that to me, you're scaring me. Let's just do this. Why did it fail? Yeah. Oh. Yeah. Can it actually optimize this way? I wonder. I mean, look, foo has fewer instructions. This is just the case. It just is the case. This is foo. Yeah, I mean, just ignore the last part. So I think that makes sense. I mean, yeah, the logic's a bit harder to follow. But at the end of the day, this is what you're doing. Because these are synonymous. And if you have, what's good about this is that if you have the edge case, if you have the edge case that someone is calling, someone wants to insert a null value, which I don't check here, then this is fine. Because, yeah, this just sets the tombstone to 0. Doesn't no nulls, null error here, no problems basically. Yeah, although technically I could just disallow that at all because it's not good semantics, but it's safe. Okay, so that's important. What's happening here? Yeah. So I think this is just better. And if I now recompile, and I'm gonna test a few cases. Yes, I'm gonna test deleting a deletion. Yeah, all those 4 cases I had. So make ldb run. So deleting a non-existent, did I have that in my... Oh, well, yeah, that's also a thing. See? You're trying to delete something that doesn't exist. So that's also another case. Because, yeah, well, see, there's a bug. If you delete something that doesn't exist, what happens? Right, so yeah, we have a few interesting cases in reality. But let's start with the ones we had. So if you try to delete a deleted, so I'm gonna delete deleted x, then you delete deleted, and then you delete it again. Nothing happens. If you try to get it, nothing happens. So that's good. Then the other case is, yeah, delete an existing. We tried that. So we try to now upsert a deleted. That should work. And the size should be correct. So that's 7, and that's 8, that's 15. And we have to upsert the existing. So that should be 8. Yeah. And if we don't get this, I should get D. If I delete it, I should get 1. Yeah, that works. Okay, well, good. Although, where are we going to the index? Ah, yeah, because it tries to search in the mem tables and it already registered some mem tables because they're already there. I'm gonna try something else. By the way, I need to delete these because not needed. Yeah, but it's gonna break my state because it's gonna think it has them. So I have to restart. Right, you delete something that, I mean, you try to get something that doesn't exist. You try to delete something. No, you try to set deleted to D, and you delete it. And you set deleted to DD, and you get it, and you delete it, and you delete it again. Yeah, this is fine. And if I go set 1, 2, total size should be 2 plus 7, the key 9. Yeah, I think I'm gonna add some more values to test some weird cases. Now I'm gonna get deleted. Oh yeah, it is invalid. Okay. Yeah, okay, this is fine. So, fix the bug. fix delete logic, but I'm gonna rewrite this anyway. I'm just something we need to take care of. Okay. So we'll have to get back to merging. So let me show you kind of the idea behind this whole thing. What do I have here? Some stuff. Okay, so the whole point of what I'm working on, I need a grid. Where the hell are the options? Grid and option as, okay. So yeah, whatever. Okay, so here's the idea. This is how I'm gonna have my thing set up. By the way, do I have some symbols here? No. System design components. Whatever. I got 39. Oh no, I didn't want these. Can I just reset? Thank you. I wish they had icons without text, but yeah, I think you can remove it. Okay. Yeah, database concepts. I just need like computer components, like a disk. Where are disks? It's kind of better, but not the best. Why am I wasting time with this? Yeah, kind of does the job. Okay, whatever. Okay, so, oops, let's kind of zoom in. Right, so probably let's start with the top of the hierarchy. So I'm gonna first draw a boundary, and at the top we have, can I just add a rule for this website to like disable it forever? Yes, I can. Yay, okay, https xcalidraw.com. Thank you, save, and refresh. Yay, okay. So here's the two, so this is memory. I want my medium to be like decently large in my Excel. So I kind of need to draw with that in mind. Okay, let me go. Whatever. Yeah, these customs. Okay. And I'm gonna have disk. So disk. And then In memory, I'm going to have maybe I have a nice icon for this. I like this enough, so this is my, yeah, I'm gonna just active mem table, so I'm gonna call it. This stuff. Okay, and this is my active mem table, and I'm gonna group these two things together. Also, temporarily, I'm gonna have inactive. Can I just, no, I don't want an arrow. Table. I'm gonna have like a little queue here. Okay, so this is my this is my queue. So this is my queue. And I'm gonna take stuff off this queue every now and then. Dump queue, I'm gonna call it. Okay. And so these are going to get, so I'm gonna have like a then also called level 0 here, level 0, this aligned as such. And here I'm gonna have so-called SS table files. So they're just gonna be files, sorted files. So I guess what's a nice file? Yeah, it's this. So perhaps just make this larger and make this way smaller. Okay. Okay, way smaller doesn't work that well. And I'm gonna change this text SS table with I'm sort of getting irritated by the grid. I guess it's because I should have zoomed way out and used a way finer grid, but okay. I'm gonna disable this. I'm getting frustrated. My sensitivity is horrible. Oh. Okay, so if I have just no grid for now because this is killing me. But with some snapping, please. Preferences, snap. Yes, this is what I wanted. Okay. So I'm gonna have a bunch of these. Okay. And you need to remember one thing, and that's that so this is kind of the way it goes. You're going to get a dump. So exactly each one is going to become one of these. Yeah, and these are sorted. That's why they're called SS tables. Oh, this mouse is killing me. I feel like I'm gonna start doing this. These are sorted, okay? and I need to merge them because I'm going to have more levels. So if I go to levels, I'm going to move these to the side because I'm going to have more levels. So if I go, so this is level 1. So I'm also and then these are going to get merged and compacted at some point. So these kind of maybe these 3. There are some more details that I'm skipping, but let's say that something like this happens. Okay. Okay, I kind of need to adjust this guy. So let's, oops. Okay. Okay, let's say that they get merged into 1. And the idea is that during merging, so if 1 is a stable, so I'm going to just draw this like quickly. Yeah, they're sorted by age. So if you have something like key too large, key 1, v1, let's say key 2, v2, and then in this newer one, let's call it, you have key 1 x, so vv, whatever. Then you'll have in the merge, you will have something. Oh, and if this is deleted, by the way, as well, key. So I'll call this is the tombstone value. I'll just put it make it red. Oh, I can't do red for 1. Okay. Key to x. Let's make this orange again. X is my slash. Then in the merge, you will have key 1 VV, and that's it. Okay. Kind of let's replace this with this. Let's like these. Okay. So the algorithm is called the merge and compact, and I'll kind of like the compaction part is something else. That's when. So that won't happen in the first level. A compaction case is when in one SS table file you have multiple entries of the same key with later entries being newer. And you compact a single file when you kind of remove. You only keep the latest values, but in this case it doesn't happen because in our mem table our updates are how do you call it? Yeah, they don't add a new entry. They just update the old entry. So when you dump it, you only have one entry per key. So it's either the latest value or the tombstone, but you always have one value per key. And I think as things propagate down further, you might have a case where you have more entries per key, but I'm not even sure actually, because if you do merging right, you probably will never have that happen. So you only have a key in separate files, but I'm not sure. Anyway, at level 0, there's one special case, which is why we have it. It's kind of like I'm gonna write a special function for this. Is because in level 0, or it might not even be special, so maybe I don't need to write a special function for it. Let's put it like that. Is that maybe I can make this larger? Is that the files can overlap in the key range, okay? Okay, so they can overlap in the key range, right? There's an overlap. If I can kind of draw a little blue sphere, no, sorry, ellipse. I don't like this. probably better to convert this to a... Is that even possible? Can I... Oh, can I hate this? So I'm gonna get a small... Not sloppy at all, please. Okay, super thin rectangle here. Or I will make it like this. Okay, so I will just put some text on the, not here, but on the side, saying, oops, 8, saying overlapping. And in the other layers, they're non-overlapping. And so technically, like when I merge these, as you see, I might produce, technically I will produce multiple. So, okay, kind of to make this clearer, I'm gonna wrap these guys. So I'm gonna kind of remove this little point. So let me just bring these guys here, okay? Wait. Okay. So I'm gonna kind of wrap these in something like this. And I'm gonna point all these here. And I will write somewhere. And so I will go here, oops, go next line, maybe A to H, I to U, and then V to Z or something, like whatever range. So I'm gonna split that up. So that's kind of pretty important. Right, so kind of, as you can see, kind of non-overlapping, okay? But I'm gonna do that probably later. So as my first iteration, I will go for a simpler case. Okay, I'll go for the. I have a good idea here. Nice, sorry. Okay. So in my first iteration, I won't do this splitting. I will just dump it all at once. Yeah. And then you, of course, have to handle the case where we already have these tables, like how do you merge with them? Yeah, that's not easy. So I have to consult. Actually, I'm kind of curious as to how these people do it. So inside each level, data is range partitioned into multiple SSD files. Okay, so I guess they already, when they persist, they do the splitting. That's also fine. Yeah, I mean, you can think of their level 1 as my level 0, but it doesn't matter. As you can see, yeah, so this is done correctly, and then you always have this case though. You always merge one with multiple. So that's also the difference, is that yes, so in the first time you pick up all of these and you merge the whole two levels. And then in the cascading level you always pick one. So okay, so you have to think of it like, so this is normal, this goes as a block. All these things get merged as a block. And then you get a and then you produce, first you produce, so whatever you have here, even if these were existing, you do the full merge, you do a 6-way merge in this case, like you would merge all of these into this, okay? And then from that layer on, you will only merge individual ones with a layer below, because the ranges will get finer and finer. So this will cover the span of multiple files in the one below. So it's like a tree. So kind of, you can think about it like this. So you might have, so let's go with classic full opacity. So you will have, right, this is the whole range, and then you can, I'll use numbers because it's easier for me to tell, okay? So you kind of think about it like, then this is 1 to 33, this is 34 to 66, and this is 67 to 100, okay? Not exactly right, of course. It there's always off by one kind of thing, but yeah. So this has one more element than these two. Anyway, and then of course this will be split into this. Let's say, or you can do half, but I'll do 3 here again. Could be more. So you've got this, and then you've got 23 to 33. Okay. So I'm gonna just make these smaller. So this is sort of the idea, straight lines. Okay. What are these lines? Man. I don't know if it's because I'm a non-expert user of Excalidraw, but I don't know what happens here. No, I just want to point to this. Can I just, what? Okay, I'm just gonna, yeah, whatever. And this. So that's the whole idea. Like, so yeah, in the first, you might have multiple of these that you merge into together and create all these groups. So technically you will have multiple files like this. Yeah, so multiple, and then you will have one of each here. So you create out of that. So at first I'm just going to do merging. So I'm going to be like, okay, if I have 3 files that I'm merging together, and yeah, by the way, these all have to be sorted again. So I have to merge 3 files together, or n files together, and produce a coherent result. So it's just, I'm just writing a merge function, and that's where I'm left at. So yeah, if I go to so this code base is not clean at all. I will rewrite all of this at some point, but so merge. Okay, so I have a little bit of a problem because before merging I have to like decompress files because my files are compressed which is very annoying. So yeah, as an interim goal, I need to just, I have compressed blocks, so kind of the way they look are, it's like this. I have a, like I have sizes, which were, yeah, I have like the compressed size, I have the real size, and then I have data, and then I have another block like this until done, like done, and then I have my index block. Okay, so I kind of need to, I don't know the whole size of this, so I have to like and I don't even know the whole size of the, well, I do actually, I can get the whole size of the yeah, so here in my get data block I can return another object, which is uint u64, probably too big, but it's fine. Data block size, okay, and so I have to go data block size index offset. Okay, this is kind of it, and my index offset is 32, so I'm just gonna do a nice cast here. Well, I guess if that's 32, I can keep this to 32. What? No. This is what I meant. Okay. Yeah. So I'm gonna keep this. So when I get my data block, and I will go. Does this return? No, this returns the entire. This doesn't return the block for one, right? Yeah, no, this is actually the whole, so this is kind of wrong. Okay, this is the whole data block. Okay, so I'm gonna go char star data block, and before that, u32 data block size is ss table get data block ss. Oh yeah, no, this is fine. This is fine because I have multiple ss tables, so I have to go. I'm gonna kind of rename this compressed data blocks, or just call them data blocks. It's obvious they're compressed. Sizes, ss table length, and I'm gonna here I'm gonna go data block sizes I. Oops. So I'm gonna write that. Okay. So now I have my data blocks and their sizes. Cool. So once I get all of them, I'm gonna. This is all embarrassingly non-parallel, which is bad, but it's okay. Okay, and then before I do this, I'm gonna create a function that decompresses the whole data block, okay? Because that's better. I need the whole block anyway. I might have a function that only does a single, okay. Maybe let's go like this as well. Okay, and here actually I will go decompressed block, so I'm gonna provide whatever. I'm gonna get a pointer But I don't know the allocation. Oh, that's... Yeah, that's completely fine. No, I need a pointer to a pointer. Okay, so this is the idea. Okay, so this does 1 and just writes it in the block I give it. But instead of... What if I just want to write it out somewhere, okay? Yeah. Because I know how much size there is. I mean, that's not... Okay, so that information is nice when I have one block, but if I just know the whole size of the thing, I will just... I need... Okay. Basically, I don't need to allocate for each little block within the whole data section. Probably should call it data section. Yeah, so for a little block, because I'm going to... When I decompress the whole data section, which is what I want, for now at least, that's what I want to just give it a scratch space for the whole data section. But I don't know the size of the decompressed variant. I know how much it is compressed. Not great. Because if I don't have enough space, it's kind of... I can do something smart. Just sort of guess it, and I mean have a pool kind of where just add one more block if I don't have it. And keep an area, yeah, just like a byte buffer, and like estimate how large it might be. Yeah, okay. Need to make the decision, but I'm first gonna take a break. So, see you. Okay. So I just realized I don't need to care about the size beforehand because I'm anyway writing to a file. So I'll just write to a file and I'm done. So yeah. Yeah, I don't need to care. Or, okay, this is making me regret the way I did this because I can't just write to a file. Okay, here's the problem. Actually, I need to write a compressed version to the file, so I can decompress and write. And I also can't not decompress at all because my keys are also compressed, which means for me to even know, because the merge is based on the keys, like when you merge, you need to keep it sorted. That's the whole point. So you want to merge, like in merge sort, you have already sorted lists and you merge them. So you need to know, during the merging, you need to compare the keys. And to get those, I have to decompress. Yeah, I have to decompress, compare keys, compress again, write. And so in that case, what I would be doing is I would be decompressing one, like at any point during the merge, I'm reading the first like the keys from each table where my cursor is at, like where my index is at. Just like in merge sort, you start at position 0 for both, and then if one's smaller, you take the smaller one, put it in the new array, and you bump the index by 1, so you move to the next one, and then you move to the next one depending on the comparison. And in my case, I can do that, but first, the idea would be whatever positions I'm at, let's say I'm at position 0, I decompress one block for each thing list I'm merging. I find the smallest one, I compress it again, or I don't compress it in this case. Probably what I do is I just write a file in the compressed version because I keep track of the compressed version. The problem is I'm wondering what happens when I have like tombstones. No, I think that case is taken care of. The tombstone is just a special kind of entry. And it can't come later because the keys are sorted. The whole point with the compaction is that the keys are always sorted. So you don't have to worry about it. Yeah, you never have to worry that a key can come later. It's sorted. And level 0, at least SS tables, they always have one entry per key. It's either a tombstone or like an actual value, but they always have one entry per key. So that's not a problem. I just look at if it's a tombstone. Okay. I'm getting confused a little bit because in Kleppman's book, Designing Data-Intensive Applications, he starts with a case where you're not keeping them sorted, so there's no sorting. It's just an append-only log, and in that case, he talks about compaction, which is basically what I explained before. Okay. So that simplifies it. It's still not ideal, I have to say, that I have to decompress just to read the key, because why do this work? Like, you're not reading just for writing. Well, okay, yeah, you are reading, but what I'm saying is you want it to be such that it's easy to, it's always like keys are never compressed, or rather, they're compressed in a different way, or it's just, you really don't want your merging to have to decompress something. You only want to decompress your values. That's kind of the idea. So you want to decompress on a GET request that goes on to an SS table because you need the value. But when you're doing these kind of operations, you don't want to decompress. Of course, you also want to compress keys in some way. Naturally, you want to compress keys because you still want to save on space, but you want to compress keys in a way that makes this kind of operation, this scanning sort of thing, nice. And what you need to realize is that if your keys are anyway sorted, or you keep them in sorted order, you don't have to compress them naively. So you have to think about ways of compressing sorted elements in a smart way. And yeah, that's I mean, okay, I'm kind of leading with it because I know what kind of algorithms, for example, RocksDB uses. They use prefix compression. So what they do is they store the shared prefix, like if you have key, like if you have links, if you have like youtube.com and then you have youtube.com/a, then of course these come in sorted order like that, so they store youtube.com, and for the other key they just store the /a, so they keep the shared part. And they always do shared with respect to the previous entry, and that works out quite well. I think, no, they don't even, no, they don't do it with respect to the previous entry. I think they do it with respect to like this base. I'm not sure. Anyway, at any rate, that's how they do it. So it's kind of easy to then, because anyway you're going through keys linearly, I mean forwards, let's say, you will have seen the previous shared key by the time you get to this one. So you don't need to do any decompression, you just kind of keep that in memory. So, because you're always doing forwards operations, and prefix compression is meant for something like that, not like suffix. So, and you will only ever do, even when you have range scans, you will do forwards, traversals, and when you search and insert whatever, in insertion, you just do binary search. But whatever. What I'm saying is, in these kinds of linear operations that you have to do, where you scan through something, you always do it forwards in one direction. So if you prefix compress, it's kind of very natural. Okay. So I'm kind of torn. I would like to implement prefix compression. Maybe it is better, but I'm already here, so I think I'm gonna try it out this way, just to have this as a, I mean, it's gonna be easier or more straightforward. At least it's just, I already have the compression code there, so I don't have to change anything. And yeah, we can also test it out later at some point, which is better. And I also don't know if RocksDB compresses values. So they prefix compress keys, but I don't know what they do to values. Anyway. Anyway, okay. Just tired. Okay. I also realized that on phones it's kind of hard to see the font. Let me see what it's like on the web. So I'm gonna watch my own stream. I guess it is readable. Maybe it could be enlarged a little bit, but I have no audience, so Who cares? No, come on, I'm being stupid. I have to zoom in a bit. I think this is fine. Oops, that's not what I wanted. Just gonna go full screen, or rather maximize. Okay. What the hell happened? Oh my god, the terminal is dying. I hate this. Yay, thank you. Okay, anyway, where was I? I was here. Let's see if it's more readable now. It looks better. So I'm fine with this. Yeah, okay. Okay, so I have to do decompression on demand. Basically, yeah. I have to do decompression on demand. Meaning, when I'm at this part, right, so I will read the data blocks. And then at every point here, in here, I will do my I will call my decompress function. So I guess no, so none of this, because I'm gonna get the data blocks. And then what does this even do in the beginning? Okay, this does the initial population, but this is wrong because I have to do the initial read. Okay, maybe I can, but at any rate, maybe it's a do while or whatever. Who cares? Yeah, technically it just can be put in here. You have to deserialize that block anyway. Okay, so I will kind of decompress and deserialize it once. Or no, I will go jar decompressed block data blocks I CBI int compressed block size uncompressed size. Yeah, I'm gonna go here with compressed, uncompressed. Yeah. I have to. Yeah, so maybe should I alloc, realloc, alloc, realloc? I kind of don't like it. I would like to reuse it, but I don't know this. I don't know the size. Like, Look, if I get the data block size back and I divide it by my batch size and account for something, I will know. Okay, that's the idea. Because I know how I know my batch size. Okay, this is great. So I will go like I will keep on. I don't know if this is better, by the way. Like I'm doing here, like arrays. I'm doing a struct of arrays instead of array structs. Okay, estimated that single compressed block size, something like that. I guess it should be the same problem, but okay. I will go with estimated single compressed size will be data block sizes I divided by batch something. Okay, where's the batch size? Should be a constant, I would say. Yeah. Batch k batch size. Whatever. Yeah, whatever. Okay, so let's use k batch size. Okay, so plus, but the thing is, yeah, that's the average, and I batch on. This is bad because I batch on just number and not size. Do I batch on size? No, I don't really look at. So this is a really bad way to estimate. You can have you can technically like have it dominated by just because it's not equidistant patches. So like I can just dominate one block and can't even do this. It's gonna be stupid. I'm gonna you know what? Yeah, screw it. I'm gonna do something very inefficient. I'm gonna free the decompress. Oops, decompressed. Bad because you allocate, free allocate, pre-allocate, pre-allocate. It's kind of annoying. It's a cursor. It's fine, that doesn't need to move. But the next time you read the data blocks, so it has to be plus, right, so you have to do data blocks I plus or equal to compressed block size. Yeah, you have to move the block, right? But you lose X. That's why you have to have a cursor. Cursors. because these can move, but you can't move that. Then you can't free it. They need to be freed at the end. I'm gonna, yeah, once I'm done, free blocks I, for example, because they're all malloc. Okay, okay, so that gives me some so that reads without the values. Doesn't make sense to read without the values, does it? No. Why read it without the values so I can read the values later? I mean, okay, fine. Let's read without the values. So we have the cursor. So we read the block first. That's fine. So we read everything up to the values. We have them in pairs. Then you do this loop where you find the smallest one. Then you go to cursors of the minimum index. While you've already moved those other indexes, like that's no bueno. That's why you don't move them here. You move them at the end, and you have to only move one, right? Yeah, you can't just because you decompress, you can't move them. So you move that by the pairs key length, value length, twice the string size, tombstone, and the rest you keep where they were. And now you just have to deserialize a single value. Right, there's the tag. Is there the tag? The tag is there. Did I? Yeah, that's deserialized. That's fine. And so now I need to get the value. So before you move it, here's what you do. Oops, value. But that hasn't been read. That's the problem. Okay. That's easy to read. So you just go to pairs min index. No, sorry, you go no. Just. All right, so you've moved. That's what you've read thus far anyway. And now right, so now mem copy into value length at cursors min index the key as string size. Right, because when you deserialized it, you memalloc pair key. How does this even work? Where are the pairs? I'm copying something into something that I haven't allocated. That's not great. I have to allocate something. This is bad. Pair key data is pair key length. Yeah, sorry. There's also the function lstring create from buffer, which is key length, and the buffer I could just say is the cursor. I mean, this is kind of what it's meant for, if you think about it. Lstring C. It is what it is. Yeah. It's kind of, I hate this. Oh, sorry. No, certainly not. It's fine. Okay, so you don't have to. No, you do have to move that. But yeah, you can just set this. So that's been allocated now. There's an allocation. And kind of, now you have to do a string. It's because I want to discard, like I don't want to keep the pointer anywhere. I just want to, well, I thought it would also be discarded. It's just a value. Wait, sorry. What did this do again? Yeah, this mallocs the whole string in there. No. Create from buff mallocs the entire string as well. So I don't want that. I need to create some better utility functions here. Oh my god, this is bad. That had to be added. Okay, and same thing here. I have to now value data malloc value length, and then do a memcopy on value data from. Yes, after this part, I have to do a KL size. Oh, sorry. Cursors, main index. Fucking hell. It's a C project. Why are you suggesting C++ ideas? Okay. Of course not that. And now do this. So you can remove that, and now you can write. Well, now you can't write that. Now you have to write the compressed block to which you don't have any more access because you've read it. Do you? Wait. I don't even know if this is correct because a cursor is. Yeah, okay, no, that's fine. So just to read this, I'm moving it, which I don't want to do. Which I don't want to do. Yeah, I don't want to write the key value pair. I want to write the whole block. Okay, so to get the value. No. Okay, here's what I'll do. I have to go. I will write this. All right, value offset is this. Okay. And then value, so value offset. Again, no, so value offset plus k of string size. No. Once I have, no, I don't even need to copy, no, I don't need to copy the value, I need to copy the whole. No, wait, I'm wrong. I'm wrong again. Okay, look. I have to copy the key value pairs one by one and then compress the whole file. Yes, okay. Here's the thing. Okay. Let's say SSD1 has, let's say, Alabama. So in one block, so I'll go compressed block 1. And I'll go with Antioch, Burma, Cyprus, some country names, okay? Some value, right? But we care about keys. Okay. And let's see, okay. And we've got, then you have like a compressed block 2. I don't know, like Danzig, Estonia, Finland, okay. At the same time, let's just kind of copy this as a block, and you have SSD2, which has, so maybe Alabama, Boston, I don't know, Canada, right? And whatever, I mean, you will, Dorset, I don't know, I'm going to use another word, and Fiji. Okay, so here's how it goes. I decompress one block, okay? So then I have access to these. I compare. Then I can't write the whole block because Burma is less than Boston. I can't write I always have to write key by key. So I write Antioch. So then merged is, you first have to write Antioch. And then you have to write Alabama. No, sorry, Alabama, then Antioch. Antioch, okay? Then you've got Boston, then you've got Burma, then you've got Canada, then you've got Cyprus, okay? Etc. And then you need to merge. So you need to merge at this point after you have, if that's your batch size, okay? Because this is batch size 3. So you kind of need an interim result, like batch, compress, write, batch, compress. I mean, you can kind of do it in 2 passes, but if you do it in 1 pass, you keep a batch array, and then you dump. Okay. So you do need the value, and you can move the cursor. It doesn't matter. Okay, it doesn't matter. You can just move the cursor. So you can just do that. Okay, string size, cursor's main index plus or equal to value len. Okay, size. Okay. Oops. Okay. So and ideally, since you're using a pair, and the pair, I mean, the pair does have a value, and you just have left it empty. So what you will do instead, there's no reason to do all this. Then you do pairs. Well, no. Yeah. So I will go pairs min index. This is what you've got the key for. Value is equal to like value kind of thing. And ideally you would just, instead of that value, you will do pairs min index dot value and then do this. And then kind of but if the compiler is smart enough to do this, then I would prefer that, because I don't like writing all this stuff. Okay, I just hope the compiler just optimizes that. Okay, so this is now good. So cursor only moves for min index. Okay. Of course, it's not great that I have to kind of, no, but these are all temporary. It's great. Or like, yeah, multiple time comparisons. Of course, you kind of waste on some comparisons because you already compare, right? Look, in any one round, if you have, let's say, 10 things you're merging, in any one round, you've already done at least 9 comparisons that you're going to do in the next round, right? Because you're going to compare one to the next, to the next, to the next. Oh no, actually you're only comparing to the minimum. But yeah, okay, yeah, you have some comparisons that you're like wasting, let's put it like that. Doesn't matter. You might even not have any, actually, if you think about it. You're only comparing with a minimum key. Well, yeah, in certain cases, if you have a degraded case of, let's say, in descending order, then you've compared everyone with the other. So if you keep going in the next iteration, you'll have something like that probably again. And you're kind of wasting computation, but that's fine, I don't care. Okay, so now we've got the value in pairs. Now I need to add this to batch. I need to add this to the batch. This is very important. I need to add this to batch, so I need an array. Okay, so I'm gonna create like a char batch k batch size, like, and then batch index 0, of course. Int, yeah. So then I go batch batch index is equal to, oops, sorry, that's an SST pair. Struct SST pair. It's going to be pairs. Yeah, I have to save this. And then I prefer doing this. Then I check if batch index has reached batch size. Oops, keyvalue size. Then I need to dump, and then of course I need to reset my batch index. Yeah, okay, let's use U32, okay. Okay. So I'm gonna set that to 0, and I'm gonna dump. And here, well, no, compress and dump. So you already have that, which is nice. This does the whole thing. Yeah, I don't know which one makes more sense. Oh no, this is fine. This is exactly it. It's an array of pairs, which by the way, I hate this. SST pairs. So that's that. I really don't want to use. I would like to use an array for the batch, honestly. Like, okay, yeah, it's fine. Yeah, okay. Batch array size new, okay, that size always, and element size is size of struct assessed pair. Right? So I just go batch array push. Oh, I know the index, don't I? I hate this. I don't really need this at all, actually, if I just manage the index. But whatever. Batch, and then the element is pairs min index. Okay, pointer. And I check if batch length is keyvalue size. Then you sorry, I just got array set length 0 batch, and this works fine in the URAC. Set length, I mean, this is so annoying. I have to check if I'm freeing. I know I'm not freeing. And why does this even have an element free function? It's supposed to store the structure. I don't even like this. Like, it's storing a raw structure. I disagree with the design decision completely. Void array set length normal, like set length no free, something like that. I hate this completely. I'm literally not even gonna just compare. I'm just gonna write literally array 0, array like make empty. I'm just gonna do this honestly, like just set it to 0. Like I don't need to free anything. Memset maybe worth it to use memset, but I'm not going to do it. URI H friggin' I don't know what I did with this interface. I desperately need to fix it. Array make empty, but whatever. Right, batch. What is data len here? Okay, so the size of this block. Okay, because it needs to be compressed, so therefore the size has to be known. Batch size in bytes. Yeah, I'm just gonna write a function for this. I get SSD pair get size. We always call a size just these two, right? No, well, you need the tombstone as well, of course. And the right. So when I call it elsewhere, like what's the data len? Like what do I put in the data len? Tag, string, everything. Okay. Of course, okay. Get size somewhere here. It's fine. Data len. Whatever, these conversions. that's going to be a plus equal. And this is going to be 0 here. And in by 0, user 2, something like that. Pet size in bytes. Out. Well, this is pretty good. Yeah, so I think this works, at least in principle. Now when we reach a bad size, we reset, we write, reset, and go back, write, reset, go back, write, reset. Yeah, although ideally, I at this point actually I would prefer to write deserialize. I would kind of prefer to write this in a readable way, because yeah, before I rely on that. So I will go on fwrite. How did fwrite even work? Okay, you've got the pointer you want to write from. I'll just write key and value, okay? So pairs min index. No, sorry, actually it's batch. How do I do they have like a get lost? They don't. Compress and write. I'm just gonna do this. Okay, I'm gonna patch item struct. Well, I know that it's that, but I have to loop over the whole thing to actually make this work. No, or just write every time, and I know. No, I can't write every time. I'm looping. Okay. So for u32 I less than batch length I plus plus, I will go this is equal to array index of batch type SST pair index, and then I'm going to write from batch item key data batch item key length once whatever into out, key is value, and that's what I'm gonna do. And I might even write, yeah, I'm gonna write a comma or something. Okay, so I'm gonna write all that out, and I'm done. And now for my limitation on a memtable limit, I'm just going to use 1 kilobyte or less, 64 kilobytes, and I'm going to make this. It's probably a bug somewhere, but okay. that worked. So now I don't know why I'm doing this, but I am. Okay, I'm gonna trigger a merge now, and it's gonna. Oh, don't tell me it doesn't have this. It's looping forever. I forgot to break. Okay, but anyway, who cares? Is there an out SSD? Yeah, there is. Oh, looks good. Looks good. What's a nice format for hex dump? Like I'd like the hex dump where I can see. Okay, examples. Oh, minus C, yeah. Minus C out. So let me just delete everything, and I'm gonna retry with some better values. Okay. Okay, so I'm gonna go like this. And then I'm gonna go I mean, the while loop is killing me because I don't have a limit. I mean, too many. It's just I can barely understand what's happening. Because my limit is so small, I'm gonna like limit this to between 30. Great. So now if I look at this, you get 30 value 30. I guess, is it so compressible really? What? Already 4 of them? Okay. Yeah, so I'm just not exiting on time. Because I'm kind of looping forever, and I guess I reach some limits. Okay, after I wrote everything. Okay, and how do I know when to exit? Okay, I'm gonna run this with GDB now, LDB, just to see where the issue happens. Run. refract rays in the decompressed block. So if I go okay. Okay, that's too big. Okay, that's interesting. How is that possible? Okay. Yeah, something weird is happening. I guess it's decompression. It's just I'm gonna set a breakpoint here and see what's up. Okay. Let's kind of split this horizontally. I need to check 0. Oops, so here it is. X down 0, 0 SST. So that looks fine. Okay, yeah. Okay, so we've got 4 bytes of this. Yeah, this is kind of the problem. I didn't move. That's not the data block. I didn't get the data block. Because my data block is... So this is index, the size of the index, offset to the index, and then you get, if I'm not mistaken, compressed block size. No, wait. There's that. Then you get compressed block size. Right, wait. I forget my format. Compress and write. That's what size is that? So it's an integer, so 4 bytes, 4 bytes. Data length as well. That's 8 bytes. Four bytes. Oh no, this is the data block, right? So yeah, these are the wait, almost. Here's so this is the tag. The tag is 1 byte or 2 bytes. Forget. The tag is 2 bytes. If I go to tag size, it's 2 bytes. So the key, right, and it's a pair. So I would expect it for a pair. The value is 2. So I'm thinking. Okay. Yes. So this is the tag. And you get the length of the string, which is 6, because you have key underscore 30, and then you've got your. Okay, and so this part should be the block, the actual data length, and this is, so there are, I think, these two extra bytes that I can't place. Where the hell am I? So this get data block thing isn't making me happy. Nope. No. Nope, because you've got the. No, Emma, wait. No, that's not right. So there's a footer at the end. So this is what I remove. And my data starts right at the beginning, technically. So I don't understand if I look at why do I have all this? Like, I really don't understand why I have all that. If I look in the first file, these are awfully similar, these values. I don't know what's up with them. But that doesn't look right. It's supposed to start off directly at. Hunk tag. Does that have the tag? Tag key value. Tag key value. Yeah, so that's correct. I mean, it's like this. As I said, I've got 4 and 4. These are fine. These two are what I cannot. Wait, I compress and write. What do I actually dump? I dump once the compressed block size, once the actual data length, and then I write the compressed block. Yeah, I actually don't know. I mean, if I take this number at face value as the compressed block size, makes sense. But I still cannot make sense. Like you get 4, you got 8 bytes, then you get these 2 bytes here, and then in the tag, like what are these 2 bytes? It's really hard to understand here. So what is the compressed block size then? It's 61. Yeah, so there's something wrong there. 61 makes sense. Makes a lot of sense, I would say. So what is 61 in Python? That's 3D. So that's 7, 8, 9, 10, A, B, C, D. So technically this is the compressed block part, it's saying. Then the other compressed block has to start. Or is that the index? Can't be the index, right? The whole point I thought was to skip it. And the vice versa. X, sorry, 1, 3, 2, 3, 4. So it's reading that as the uncompressed size. And not reading this. It's skipping over these 4 bytes. Decompressed block. block. That's because ints are 60. Ints are 64 here. Oh man, this is really frustrating. Integers are 64-bit. Either that or this is writing 8 bytes. No, it's not writing 8 bytes. It can't be. Size of data line. Yeah, but I'm using ints here, so what is going on? Let me try a new project. Oh, it is 4. At any rate, it shouldn't have mattered, right? What the fuck just happened? Did this just really undo all my changes? What? Whoa. Oh, this is really bad. I think I broke my knee of him. What the fuck? Keep this as inted. Oh no, that's fine. Size of not that, right? What this is holding look. This isn't decompressing the block. Yeah, that's the problem. What? What did I think? I'm not even decompressing. Of course this doesn't work. Oh. Bruh. No. This is compressed for decompress. Decompressed malloc data len, of course. So that's decompressed. Whoa! Oh, something's wrong with this shit. Keep losing my marker. Ah, this is what you get for using them. Where's this logic? Okay, my destination is decompressed. My buffer is compressed. My block yeah, that's my ln and my compressed block size. Bum, bum. Return decompressed, of course. Oh, wow, what a critical mistake. So that made sense. Although I still don't, that still doesn't explain a lot, but okay. I'm gonna close this one now. All right, I'll remove that stuff. Let's start this right here. All right. So that looks fine for now. Well, it looks better, but nothing looks fine after that, I think. Length is 0 everywhere, which is how. What is? Can someone? How come that sometimes, like if I'm not pressing GG. I'm copying stuff from the cursor and it's all zeros. It's crazy. Because, well, what would I call this? The decompressed block. Now I need to move the mem copy. Compressed block plus 8 compressed block size. Technically, I don't even need to do that actually. Why don't I go block plus 8 move 8 from there. Worse. But this is better now. Yeah, look at this. Look at this. Frustrating. I need to add a. Okay, I'm gonna remove everything from there. Quit. Make. Okay, nothing. Breakpoint compress block. Nope. Compress block. Decompress block. Okay, run. Alright, so we are at decompressed block. What's the block, first of all? P-array. Yep. Oh, so we've got the tag. Oh, you got this stuff. Which is the length, the tag, and then we've got 10 bytes. Again, this is sort of the funny stuff. 10 bytes. God knows why, but we have 10 bytes. So we kind of, what is it now? Right, 61. Sensible. Yep. Ooh. Bum 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 bum. Great. Yeah, size of a pointer. Move it by the size of a pointer, and you think it'll work. Yeah. I'll run it again. Kind of same breakpoint basically. I'm just gonna run it and then see. Okay. Yes. Sorry. Is that a sensible value? Well, no, they're both sensible values. All right. P array 12 decompressed. Underscore 30. Ah, this can't make sense. Why 30? Oh, I already moved the block. So actually, no, news. What did I, again this stuff, I don't know what's happening. Okay, no, I don't need to do that because it's already done. That's the point. Okay, make, I'm just gonna go for it. No, let's remove first. Start. Okay, X dump. No, X dump out. Brr, nothing? Really? It's worse. Okay, maybe. Okay. I don't know what's up. Look at this. Look at this nice bug. I switch tabs, and then whatever I press, it goes up. And it's not just this. Look at that. It automatically adds. I have no idea. It's only when I switch tabs. Yeah. And the only way to fix it is if I switch tabs and click something. Yeah, I kind of escape. Weird. Decompress block. And then the other part where I need to like look at kind of what came out is that deserialize without breakpoint. Pair deserialize without else. Okay, now we can run it. Now we can first just do this. Now let's go to the merge. Right, bang, 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 bang. So now if I go to P8, this is what's funny because what is that? That's size 4, that's size 4, but if you actually look at where the block starts from, if you go P array, oh no, it's fixed. Oh yeah, well no, sorry, it's moved, but no, you see, you get these. Ah, okay, so these are just added by the, like, yeah, so these exist, but they don't exist here because that's part of, okay. So now that's correct. So I have to continue. Okay, now we are here. So if I look at cursor, P array 16 cursor, I get exactly what I need. So get the tag. So next I go pair tag, still correct. Move by tag size. Then P pair key length 6, that's correct. If I go to cursor, I am at key underscore correct. So I allocate some memory, I'm copy now. If I go to P pair key data, perfect, it's key 30. So I move that by length, that's right. Do I have a tombstone actually? Yeah, that's a tombstone, that's a 0 value, then length. P size of pair tombstone is what? 1. Fair enough. No, that's also fine. Length. So if I go to pair value length, it's 6, it's perfect, and that's moved. So this read is fine, okay? So this read into pairs up to that. And then I free it because I don't need it anymore. Correct. I free it because I don't need it anymore. Already copied. And I'm only freeing the big block, so I'm not freeing the values within. Anyway, they're created there. Okay. So this is now, if I go to SSD pair print, so now they are the same value. Okay, so what do I do? Then I compare, I find the minimum. And then it's going to be 1. Yes. Zero 0602. Thought it should have been 00. I mean, even I got value underscore 9. Might be 9, but it's still not this, whatever this is. Wait, what? Why didn't that move? No, but the cursor hasn't even moved to the key. This is the problem. This doesn't move the cursor. The cursor contains compressed data, so it doesn't even make sense what I'm doing here. I actually, you can't even read the values from the cursor, like what I'm trying to do here, because it's compressed. It's compressed. The cursor doesn't have decompressed data, it has compressed data. So you need to like, no, this is not gonna work. I've complicated it and I haven't like written it down, so this is no way to work. When I decompress a block, why am I discarding the decompression? I will I need to save those keys that that I've already decompressed. Oh, yeah, okay, I'm gonna take a break. My brain's not working. Yay, okay, this works. Yeah, I'm gonna use this to show some notes. Alright, continuing the break. Okay, I'm back with a food break, but yeah. Okay, it's too hot. Yeah, so the idea is, the whole point of the problems I'm facing is A, like not sketching out the argument in notes. And also, of course, like if you try to do something, like if I took the object-oriented approach, I would have been done quicker, and I wouldn't have thought about efficiency and doing things in the same cycle. Like I could have just at first read everything, then merge everything, or like strategies like that. So, and then I'm kind of using very primitive data structures, and I'm kind of losing the context. So, yeah, need to kind of sketch the argument out or the plan out better. But it's taking me embarrassingly long. It's been streaming for 3.5 hours. So yeah. But yeah, no AI. So that's kind of the fun part. That, I mean, just having to deal with the details yourself. Yeah. So let's think of the case with two. So So I'll call this C1, and this contains 2k and whatever. And this is so this is SST1. See, again, you get gonna use primes. K1 prime. K prime. Okay, yeah. So the idea is you work on key level, but compressions are on multiple key levels, so you kind of have to take advantage of that fact. So the first step you need to do is get key 1 and key 1. But in order to do that, you need to decompress. Oops, sorry. And if you think about it, what will happen later is that you might be at C2 for one SST and at C1 for the other. So you kind of also need to keep track of these indices. So I would say once you decompress a block, you keep that in memory. And your cursor is always a pointer to the decompressed block. That's an important part. I mean, maybe you need another variable like a read cursor or whatever, but you need that. I don't know if you can multi-purpose like your cursor to do both. I don't think so. And yeah, of course the so you have two cursors at all times. You have the cursor for the things like this. I'll call this the compressed cursor, so it's in the beginning pointing here, and then this one is like pointing somewhere within each key value inside. So I would say, so if you had like, you know, key 2 and key 3, and so this will point at stuff like that. So you need both. Yeah, and the moves with each, like, how do I say this? Main index loop, I guess, by 1, and this moves with every decompression. You kind of need to know if you need to read the next one, decompress the next block for one of this table. So yeah, I probably like need to have a condition somehow. Okay. So yeah, I currently I just keep adding variables. Very bad. Now I also see why other languages have slices. Like, for me to know the boundary of this thing, I always need to check with this. Not so great. can I use my byte rings here? Or just my arrays? I need like a capacity. I'll just use my byte rings. I hope that that data structure works well. So I need an array of byte rings. So I need byte ring decompressed buffs as a stable length. Byte ring, yeah. What now? Oh, struct. Okay. So technically, what if I just return a byte ring? Decompressed block PR. Okay. Struct byte ring br malloc. Well, no, I think you can just byte ring initialize a capacity of compressed block size. I mean, again, every time you use an abstraction, it's like if I just then go push, like this will literally do a check. But I know I have capacity. I don't want to do these checks. I think I'll just go data. Oh wait, no. I want to pop whatever I consume. So it's fine. I think computers are fast enough for this. This is not such a high overhead data structure. Okay. So I'm kind of trying to find a way. So in the decompressed, I always go into the data. That's completely fine. Yeah, but how do I need to, again, this is one of those things where this function is meant to work on char stars and I can't really make it work here. I have to like copy it. Okay, I have to copy something. I'm gonna go for it. And then I'm gonna go BR, well, start is gonna be 0, BR size is gonna be compressed block size. Cap is cap. This is completely fine. And we go BR. Decompressed. Okay. So, oh, by the way, you're not seeing anything because I'm my iPad's. Great. Let me hide this. Yeah, I've written some code. So I'm just using my byte ring, which is my internal like class, which is a byte buffer, but you know, like a ring structure, which is pretty convenient. Okay. So if I go to decompressed block, instead of using that, I can use, yes, I can say decompressed buffs, but it's gonna be like this. At I is equal to decompressed block BR So quite literally, I will just copy this and say decompress buffs IBR, kind of like that. So byte ring pop first n into decompressed buffs min index is going to be exactly this. And popping, yeah. Um, this is so hard. Because you have to use the start. This copies into a buffer, so it's perfect. Oops, no, so sorry, decompressed pass min index. Copies into value length, KL string count size. Yeah, it's just memory. It would be nice to have a like a pop with a destination kind of thing. That's fine. And you can do that. Oh, no, you can't, because you only do that in batches. So if the I size equals to its capacity, then you do that. Otherwise you don't. So only if it's full. Well, no, not true. Now I'm getting into manually managing my byte ring, which is not a good idea. Yeah, but it's bad. I need to no, I need to. Oh, it's not interchangeable. That's kind of the problem. Okay, well, another break. actually need a different data structure. I need a static array with a cursor. That's it. I just need a static array with a cursor. Nothing else. Literally, that's all I need. I don't know if there's a way to do it. I mean, of course there is, but what I mean is, when I say array, I really mean it has to be on this stack frame. Oh crap! Because this is just, I don't need all the checks. I know, I just need bounds checks, but like, I don't know. Can I create this thing? Struct cursor array. I don't know. It's gonna have a capacity, the index, size, the index, or the cursor, and then the array itself, which you can't do this, I think. Of course you can't do this. I think pointer is fine. And when I create it, so I'll go I will pass it, so basically cursor array in it is just going to be, it's going to return a cursor array, pointer to it at least, and you're just going to provide a, and so I don't even want to malloc this object. Like, no, just no. You just provide me a, okay, so, oops. So I just go CA size. Yeah, I don't even need this method. I just create the thing I need. Yeah, so literally, for example, if you go, so I would say struct array tc as tables, not even that, so I would literally go dci data is a decompressed block from cursors. Just copy this. So I'll just go DCI data. Okay, yeah, and then you just go DCI size. Cursor is always 0. And DCI cursor is 0. And size is compressed block size. No, uncompressed size. Yeah, that's it. And then when you need to deserialize, the deserializer is not going to take that. Well, rather, let's so you just give it a cursor array instead. Okay, so you just give it a struct cursor array ca that doesn't exist here, so I will cursor array. So I'm just gonna do it here. So you just go CA cursor. That's it. Yeah, you just go here. You just replace every cursor. Oops, not two spaces. Cursor with CA cursor, and every comma cursor, including that, comma cursor with comma CA data. That's it. And at every point, you always point at, at every point, you write at, wherever you have CA data, you go at CA data, CA cursor. Yay! So that's it. Just move the cursor, always access the cursor. It's gonna be within limits. And that's it. Pair deserialize without vowels CA, and you don't have to deal with that. Yep. Bang, and well, you're done. And then you only, you don't even care about it. The cursor is taken care of, and you only decompress, right? So you only, so if DCI so only if it's empty. If it's not empty, keep doing this. I mean, I don't know. Does I don't know if C does. RC array 0. So we do this. I mean, maybe there's a more intelligent check here. Zero initializing of VLAC. Oh, you can just do size of DC. It's even nicer. Oops. Okay. So we don't care about this either. Yeah, if you've reached the limit and you know you reached your limit. How do you know, actually? This is a good question. if the cursor is equal to the cap, then we've reached the end. And in the beginning they'll always be equal because they're 0. So you go DC. Yes, and at this point you need to jump the decompressed cursor completely. So ideally you would do it inside of this thing, but that's fine. We can just go cursors I plus or equal to compressed block size. Yep. And it would be nice if we could kind of name these. I will say yeah, I mean, I think cursors is fine. Yeah. But DC here is pretty bad, I have to say, so I'm kind of gonna, I will say DC block cursors. Decompress block cursors, I guess, yeah. I think the rest is fine. I haven't checked. So we get the value, push, batch, dump. Okay, let's try it. No guarantees. Remove, make, oh, algorithm. Oh God. done. Yeah. GDB. Did I remove everything I did? Run. Yeah. Oops. What? Oh, not GDB. Okay. Next dump. Woohoo! Great. Yeah, typical C memory error. Oh, great. Yeah, nice buffer overflow. Yeah, security issues. Let's go. God, this is bad. Where the hell did I? It's even. I thought I even break somewhere. The first batch item is done well. Let me go with int iteration 1, printf iteration iteration. Then I will go. I'll go like this. Iter d ssx d d cursor equal to size, right? So you go iteration I. Then I want to see. Do I jump well enough here? Key string. Well, tag. Why do I not jump over the tag? I think that's bad, probably. Yeah, for sure that's a K tag size plus. Because if you preview hunk here, size of tombstone. Yeah, I don't know. Intuitively, I think you should jump over the tag, but I'm not sure. No, the decompressed block, yeah, you have to jump over the tag, over the key, over the tombstone, over everything. At any rate, I will say that at this stage you will go iteration, mine index, and then I will say DC 0 to 32, I guess. Yes, and that's min index. Then I will go to 32 DC block cursors min. Oh, sorry. Yeah, well, data. Add plus DC block cursors cursor. That's it. Okay. I wouldn't character byte. printf as byte. Okay, percentage x2, I think. Okay. I'm gonna run this once and see what's up. If this works, great. If it doesn't, I'm gonna quit. Basically. Okay. It's alright, I want to see it as bytes. Or yeah, okay, let's try this. Remove. Oh, sorry. Make LDB run for client open client merge. Okay, so that correctly moved to value. That's what I want to use. I'm gonna keep this twice. Move make LDB run for merge. No, I meant once as a string. I'm kind of surprised. My value here is, so that's correct. Well, I don't know if it's correct. I actually don't know if it's correct. Because why is that saying value and I haven't jumped over it? It's because this moves the cursor. Yes, we agree that this will move the cursor, which makes this redundant and incorrect. Okay, correct. Make, remove, run for, and then this. Again, big problem. How's this possible? Oh! No, it's data. And then cursor. Very subtle distinction. And we have a better but wrong. VA is gone, funnily enough. Liu at this print point, that's oh no, this also reads the value. No, this reads the value's length, which actually I don't want. Why am I reading the value's length? I need to keep it for later. I will read it at this point. Makes more sense to me, personally. Make, remove, run, for, and then this. So now it's correct. I mean, these two steps are correct. 30, 31. But this adds it every time. Yeah, that's completely fine. It adds pairs. But why are the other ones wrong? That's the question. super hard to detect like where the bug is. I'm gonna set a breakpoint at SST pair deserialize without LCA. I'm gonna run this, and so I go to 4, and I go here. Okay. So what is the pair? Of course, nothing, but so that's not enough. I will say 32 maybe. LDB hex dump. Memory read count 16. Yeah, I like this. Thank you. Okay. Okay. We know this. What do we have in pair? And if I go to see a cursor, it's 6, 8. Well, the length itself is 2 bytes. 10. The tombstone is not going to be added. It's 11. That's correct. So the cursor has moved. Now we go here. So that was pairs 0, I guess. Yeah, pairs 0. Pairs 1 is nothing. So PI has been incremented. Of course, this doesn't exist, so you have to decompress the block. If I go to print memory, you will see, for example, DC block cursors I data. Perhaps more than that. Let's go for 32. Yeah, that's correct. That's perfectly normal. And the cursor has been moved. So if I go, sorry, PDC block cursors I cursor is 0. Yes, that's correct. And if I now check, oops. And for this, it's going to, it can't be 11, can it? The lengths are different. No, the key lengths are the same, so that's correct. All right, so, all right, 0, bum, 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 bum. So if I go min index, that's going to be 1. So p pairs min index to be that. And if I go to memory count, DC block cursors min index data. It's key. I think especially interesting for me is if this is done at the cursor. I need an and here. Yep, so that's at the value. Perfect, just before the value, and the value is 8 long, correct. Okay, whatever, next, 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 next. Okay, so if I kind of read the memory again, that's right. So can I see value length is 8, that's right. You increase, you allocate. Can I see value data? Also perfectly correct. And then there's that. So if I now print my cursor, yeah, I'm at the next key, got the tag. So pairs min index. Also doing fine. P batch. No length. Okay, fine. Now we push. Length has to be 1. And k batch size is 8. So we go to the next iteration. We check this. Obviously this condition doesn't apply probably. So you skip it. And now you are at 11. So if I kind of go to memory, I will use I here. I shouldn't move the key if I deserialize it. Yeah, because I don't know if that's gonna. It's no. So exactly. So here, this is a bad idea. I will go U32, I guess. I don't know what is this. Yeah, U32. Cursor is equal to CA cursor, and now everywhere I have CA cursor, I go cursor because I don't want to move it. See, I'm doing a look ahead here. Without, if I move it, then I lose that key. So this is correct, and you only move, and then you go DC block cursors, my X cursor, this moves by size. Actually, SSD pair size. I wonder if this works. No, don't bother. We go tag size. We go, and then length. I'm sorry, key. Yeah, sorry, min key length plus tombstone. Min pairs tombstone. I mean, that's kind of it. So you jump to value here. Make, remove, actually let's just do this for, that works better, but it's still wrong. Batch dumped. Where's the F right? And it's funny that somehow this case never applies or something. I don't get it. Why is it not writing? Batch item has a value. Oh, I guess it doesn't flush it. Yeah, before you leave, you gotta flush. Flush out. Flush. Do I have flush? No. Sync. Okay. Yeah, okay, I'm gonna use flush. It's fine. I still don't know where the problem is. Because if I go to 0, yeah, I do have 30 to 35 anyway only, but something wrong here. Yeah, anyway. Make, remove, start for merge hex out. Yeah. And it stops at some point. Like here. That's so funny. Key 3 and it stops. Curious. I really don't understand, like, doing fine until something. I'm gonna go. I'm gonna go to LDB. And I'm gonna set a breakpoint where. I need to check this last value, like what goes wrong. So I think I'm just gonna set a breakpoint at 718 resistance, and I'm just gonna continue until kind of like I get to where I need to get, and maybe one more at, because that's where the key gets stored. Yeah, so once I know, like once the iteration, does that happen? In which iteration does that happen? I'm gonna use this, and I'm gonna remove everything, and I'm gonna create a breakpoint at 718 persistence 18, and I'm gonna run now for it, and now merge. Okay, so iteration is probably 1. I'm gonna continue. Probably still 1. This is the other pair. Because if I check out pair 0, yeah, this is the other pair. That's fine. So now iteration is 2. Batch 0. Batch data 0 is, well, batch contains SST pairs. Yep, so that's key value. 1 hasn't been added. Oh, why are we overwriting, by the way? Wait. We only need to put something in pairs if it's needed. Yeah, I mean, this is like gonna overwrite. This is just gonna overwrite something unnecessarily. Like, right now I have at 0 the value 30. At batch, but no, I mean in pairs. P pair 0. And now this is just gonna overwrite pairs. Oh, well, it won't. It'll actually it will like deserialize it again. If you think about it, look at this. Just gonna deserialize it again, same thing. And here it's gonna replace something. Okay, yeah, and then that's just old value. And batch one, sorry, I have to go to the batch trick is this. Yeah, that, because it's smaller, and here we have nothing. So now pairs one, so this needs to be replaced anyway, and it's kind of important to see mem. Yeah, so this needs key 31 now, pair 0, because it just moved by 1. Correct. So that hasn't changed, but pair 0 will have changed. 31 now. And pairs 1 needs to remain pairs 1. And batch, let's go to to batch. So we've got, and then this case has been resolved. And now we have that. Okay. Now the question is, memory, is this in a good spot? Because this looks correct and this is wrong, and it probably is not a bug here, it's a bug elsewhere. Okay, so if I go 0 is hex dump 1, I mean 0 is fine, but 1, I mean this decompressed block is just incorrect. Interesting. Why is this decompressed block wrong? Whoa, very interesting. Because if I go to cursors one, yeah, that's exactly correct. And then you have P4, val, and then key 30 disappears. I think, is this the index? Yeah, this is the index. Which is, yeah, which means that should disappear. So this is the compressed block, and this is the decompressed block. Only key 3. I mean, this looks awfully a lot like somehow don't buy this. So value 31. Somehow that decompressed block kind of runs out of values. I don't know how to describe this. Yeah, I really don't understand this. This is completely fine up until this point, and then it kind of like goes all the way wrong. Because you look at the decompressed blocks, they're so close. Like you have 4 always in between, and then this, and then you have nothing after that. So this is saying that because this is 30, 31, 32, 33, 34, 35, 36, 37, 38, and if it's like 39, then it means this. So like halfway plus 1. So up until here is the block. So technically we're done actually for this. 42, 100. Where's that coming from? 3 times 16 plus 9, is that 100? I don't think so. Oh no, that's the true size. And decompressed, yes, correct. 64, that's 100. And it says we're halfway. Yeah, I mean, P4 has moved exactly right. Sorry, cursor has moved, so this is fine. This is correct. Cursor's on, this is correct. I read the whole blog, also apparently I did, but it's like this. Let me put it like this. So cursor, no, so literally if I read this entire block, I should have all the values. I should have 30, 31, and what happens there? So that has to be some issue with compression, decompression. Otherwise I can't explain it. I mean, it's decompressing, the first value is fine, and then it's gone. So 0 bytes overall. It's like that's a massive problem. And this has the same problem. So I'm wondering, when I call the decompress block, which calls decompress safe, if I've passed the correct arguments. I've got the source, got the destination. Oh! Oh, I hate this shit. That's literally the bug. It's compressed tank capacity. Oh man, look at this. This is what happens in C. Come on, mate. Oops, no. We have to, let's remove everything. Start this now. For merge. Yep. X dump out. That's right. Okay. Okay, so we've got merging without compression. At this point, I think we don't need the break anymore. I mean, this is the early break. We have a break somewhere, right? Yep. This is like if nothing changes. There's probably a better way, but maybe there's a bug there. I'm not sure. Oops, let's remove. Let's start, let's for it. Yeah, I knew there was a bug. This is running forever. I'm super curious what happens, like why this processed stuff, does the cursor never, is there really no pointer diff at all ever? Really? Oh, hey, I love it. I love subtle bugs. But again, this doesn't help. God knows why. Nothing left to lose. Sorry. So it's stuck at 61.57. That's before the last iteration. That just never gets. So even when it's effectively done, really, I would have expected that that's done, to be honest. So I don't know why. Really, only 60? Only 61? Seems awfully little. Actually, this is correct. This is 57. So what's the size then? Well, that's curious. What is the size? Data box size. Yeah, that's actually correct. For 69. Wow, that's wrong. Actually, it's wrong. What is this counting? If I go to Ah, -8. -8. Well, no. No. No, that can't be it. So. I mean, yeah, it is exactly 8 more, but where's the 8 coming from? Like, why is the cursor not? I mean, the data blocks need to start. The data blocks also contain the. It's a footer, so it's not a problem. But it's obviously 8 bytes from somewhere. I mean, the cursor number is correct. That's 48 plus 9, that's 57. So that's right. About the size of the compressed block. And there's only one compressed block, so. What's the index offset? 41. Ah, so the index offset is 41, but that's 39. Oh, sorry. I mean, yeah, 2 bytes difference, 41 hex. So why is that? What are these two? What are these two? Oh no, that's not even 2. No, that's way more. This is saying, so that's the size, and that's the. So 41 is here. It's way many more bytes. That's because there's a. It seems like if you look at 30, look, if it says 39, it contains this. Then you have this other block until here. And that's what exactly? That's 8 bytes exactly. 8 bytes exactly. So what are these 8 bytes for? I think this is something that's like half, like written. I mean, it can't be compressed block size here and that. Yeah, there are like just 8 bytes that I can't account for. This block says it's up to here, and then you've got another block of 8 bytes, and then you got the index. So why the hell? Yes, a 0 tag, 2 bytes size, 2 bytes. Key is 6 characters, so 1, 2, 3, 4, 5, 6. And then a 4 byte index, which is 0, and then you've got index offset, index size, perfectly fine. And you want the block, it's just 39, so obviously these I can't account for at all. Can't even like make sense of them. They look like compressed, it looks like compressed gibberish. There's like a vowel, it looks like compressed gibberish. But somehow, not up here, so why? And write. So compress and write does what, like. Yeah, I need to debug this at some point. Yeah, well, great. Let's commit everything. Debug memtable limit. Right, merge function. Convenience in URI. Yeah. Okay, I'm officially done because my brain's not working and I can't figure out where the hell that's coming from. I think at this point I should probably just rewrite it and make sure everything's fine instead of doing this crazy annoying debugging, but yeah, whatever. Right, then